Hi guys, happy Monday. Um, I decided instead of those PowerPoint slideshows to make these videos just to make it a little bit more personal. So for the rest of the semester, I will be making those videos and uploading them. Uh, also, we'll be listening to some great house music. So you're welcome. Um, My goal is again to introduce you to some basic concepts of neuroscience, sports neuroscience, that will definitely help you towards your final project. Okay, so today I'm going to do one video about, definitely this one will be about the first chapter. Hopefully tonight I'll be able to do the second one. If not tonight, I'll do my best for tomorrow. All right. Um, the neural pathway of sports actions. So what we're going to talk about today, and I have here my notes because I don't want to forget anything, is the functional organization of perception in action, action recognition and action execution, the neurophysiology of action anticipation, neurocognitive mechanism of action anticipation, and motor learning and neuroplasticity. In other words, we're going to talk a little bit about um, why we're interested in the athlete's brain, in how we can do that through sports neuroscience, and what is sports neuroscience has identified right now, especially when we talk about from taking some information from the environment, seeing or hearing, especially seeing, to doing. So the main idea, as you know from the title, is perception action relationships, and we're gonna bring that to the athlete, okay, and see what is going on there. First of all, uh, there is a big relationship and a bi-directional relationship between our body and the environment. Okay, the environment, our body receives information from the environment, right? That's what we see, and that affects our body. Okay, and then we take some action based on that. And those actions from our body affects the environment, and that keeps going back and forth. Uh, so, how do we perceive the environment? That was a big question in the past. We perceive it through experience, that is perceptual and also motor. The neuroscience recently is trying to study the athletes in order to explore their potential and how, if they think a little bit differently, if their brain functions differently than the non-athletes. So, and that's how sports neuroscience was born. It's a very new subdiscipline. Now, when there is some kind of visual stimuli through our CNS, uh, we'll go to our sensations, and then we will have some neural pattern for whatever voluntary actions we may do, because we're interested in voluntary actions for this part. Now, we we experience the environment. We experience a perception as one, right? But at the same time, there's information coming from different sources of the environment through different modalities to our brain. And our brain analyzes it and comes out as one perception, as one experience. So we have multimodality in our brain, which is really important, and I want you to understand that. But that multimodality, that's interesting in athletes, can change through training, which is important, of course. That's why we practice. All right? I hope that makes sense. Now, uh, we used to believe that the receptors, and we talked about the afferent paths and everything, are organized in one specific, there's only one specific organization. That we would call it a map, organizational map of our brain. We thought it was just one and it was stable and fixed. Later on, or now, we understand that it's not one. There are many, and they're not only many, but they're not stable. So there is a high level of plasticity again. So things can change. The map, that interconnection, that organization can change. Okay? And it has been proven that the brain of athletes is different than the brain of non-athletes, just based on that. One term I would like you to know here is the peri-personal space, is the space like right around our body, where we have some higher brain activation. And by combining the information that has to do uh, with our body and its surroundings, we know that our body itself and the very personal space, the very close environment, is well represented in our brain. But that representation, that organization, that mapping can change through practice, which again is interesting for athletes. Let's talk about perception through biological motion. How can we become aware of the things we observe? Okay, and here is when we talk about selective attention, focalization. We pick what is important for us or what's interesting, and we focus there. When we do that, there is increased activation of specific areas of the brain, right? So that makes us think that we understand movement when performed by others when we focus on specific things. Now, when we talk about athletes, do they focus on specific things when other athletes move around them? So that action recognition can lead them to anticipation. That's a very interesting thing to talk about sports. Um, which are the neural mechanisms that underline action intention. So two things I would like to know, two groups of neurons that we know so far, right? Canonical neurons are activated, are firing when we actually do something, or we actually saw the opposite that we do it, right? I play football, but also when I see a football, they fire. And then we have the mirror neurons that are activated when we actually do something, but also when somebody else does it. So we throw the ball, they're activated, somebody else is throwing the ball, and we are observing, they're activated as well. So that has some importance if you think learning something when watching a video, right? Activates your brain by just watching the same areas, the same mirror neurons. So what we need to understand from this is that action execution and action observation are closely related, right? Now we have the ecological approach by Gibson, and here I want you to know the term affordance. We talked about that in class. It's some kind of information that emerges from the relationship that we have with the environment. Okay, so it's something very different between different people in the same environment, or the same person in different environments. It's some kind of information that emerges. So that affordance is important because then how we perceive the environment becomes relevant not only with our performance, but also if we can recognize any action around us. And we have many, many examples where expert athletes are more accurate to pick up the relevant cues. They get different affordances, relevant cues of some specific domain actions compared to non-experts, or also expert watchers. And by expert watchers, we mean, let's say in sports, a coach, an agent, a referee, ESPN journalist, reporter, okay? Which I think is very important as well. Is perception predictive? Yes. When we need to interact with the environment, we need to have a representation of the motion sequence in order to predict and anticipate whatever forthcoming position of whatever creature or object we observe, a ball or a footballer. Now, when we take it in sports, of course, that ability is crucial. And the temporal occlusion paradigm shows that when we show some, let's say, videos to experts and then we cut it before the end, those expert athletes can predict the movement compared to non-experts because they can read those body kinematics and they can predict and anticipate, which is great. When we talk about the neurocognitive mechanism of action anticipation, we have two main perspectives. So one is that expertise is grounded in sensory information and internal representation stored in memories. So we have memories of compare and contrast, and that's how we have experts. The other one says that the more expertise through experience creates a heightened perceptual sensitivity to domain-specific actions. I just want you to know that I have two main perspectives right now, which are different. Okay, now are we supposed to detect deception? How useful would that be in sports, right? So for us, there are kinematics, and there are honest kinematics and there are bluffing kinematics. How can an athlete do that? And how can we identify the true intention of the actor? So we need to embody the other athlete's actions, but there are cases that we need to inhibit that because they're just faking and move to the left so they can go to the right. Okay? And there are examples, experiments with goalkeepers, and a lot of times goalkeepers are better anticipating what the player will do with the football, soccer, because they are trained not only just to check the kinematics, the body, but to focus on the ball. Okay, so they don't get in a position that somebody's bluffing and they go for it. Now, is cognition related to sports? Of course it is. Of course it is. And it's bi-directional again. Cognitive development usually produces better success in sports, and participation in sports produces higher cognitive development. Okay? Let's talk about neuroplasticity and motor learning. So, and start with physical learning. So we do know that sports participation reinforces muscular physiology. We know that. But also reinforces that neurofunctional reorganization that it takes time. It takes time. It won't happen overnight, but is that, for example, excitability of cortical spinal neurons. And that's something that comes through sports participation. So there is some kind of physical learning that affects the neurofunctionality of the athlete. Observational learning. We've talked in class about motor imagery, and we know that motor imagery works. When we compare with actual observation, action observation is a little bit more beneficial because you're actually observing something you don't have to think about, so there's no mental fatigue. And you can actually, in observation, you can acquire those more accurate parameters, such as time and force, because you see that it's harder with imagery. Of course, that really depends on the individual. And the last thing I would like you to know from this chapter is, and I find it very interesting, the very first time I read about it, I was like, oh my god. So, neurodoping. So we can facilitate the excitability of primary motor cortex, and that can actually boost motor learning. There are two ways to do this. TDCS and TACS. So we have a really low electrical, really low intensity electrical current going through our brain. It's really low, so it doesn't really activate action potential, but it's enough to activate the membrane of the neurons as a resting day. In that, when you're trying to learn something new, it can boost your performance. TACS is again low intensity, but it's rhythmic. It's a different rhythm of the current. Okay, and if we manage to synchronize that rhythm with whatever we're trying to learn in the external environment, then we even have what is called multimodal entrainment of the brain, which again boosts learning something. That's all for now from me about the very first chapter of sport neuroscience. I just want to introduce you a little bit. I hope you enjoyed it. I will try to do one more tonight, if not tonight, again tomorrow. Keep talking with your advisor, and hopefully if you are here in Plaza, you're enjoying the sun, you're not inside like me. That's all for now. Let me know if you need anything, and although at home, don't forget, lift intentionally, not habitually. Bye guys.